A ball is thrown vertically upwards. Okay, so this ball is thrown vertically upwards. So let the initial velocity be u, and it goes to a height of 20 meters. Okay, so this is the maximum height which it reaches, and then it returns to the ground. So now at the maximum height at this place, the velocity of the ball is going to be 0. So at the maximum height, the ball is at momentarily rest. What do you mean by momentarily rest? Like for some time the ball is at rest, and then the ball starts coming down. So we can write here, we can use this formula, v square equals u square plus 2 into a into s. Let us take upwards as positive. So now final velocity, which is at the maximum height, is going to be 0. U square, u we don't know, plus 2 into acceleration due to gravity, it is mentioned to take as minus as 10. So since this is downward, so this is minus 10 meter per second square. And s, so here it has reached 20 meters, so therefore the displacement is positive, so therefore s is plus 20 meters. So therefore u square becomes 2 into 20 into 10, which is 400, and now you multiply it, it's meter square per second square. So therefore u is equal to 20 meter per second. That's the initial velocity of the ball. B, final velocity of the ball on reaching the ground. Okay, so now the ball, it has reached this height of 20 meters. Okay, so this question can, the B option can be done in various ways. So first way we are seeing, so here it was having 0 velocity. Okay, at the final, at the maximum height is having 0 velocity. So we can write v square is equal to u square plus 2as. Okay, so final velocity is equal to u square, u was 0, plus 2 into, like we have taken upwards as positive, so u a is going to be minus 10 meter per second square, and the displacement. So now if you see from here, the displacement is downwards, so therefore minus 20 meters. Okay, so what is displacement? Displacement is the final position minus the initial position. So if you see the y axis, okay, since it is above, okay, so this is the final position and this is the initial position. So we can clearly see that final position is downwards. So therefore f minus I is going to be minus 20 meters. So therefore 2 into minus 10 into minus 20, which is again 400 meters square per second square. So therefore velocity is going to be plus minus root over 400, which is plus minus 20 meter per second. Now here of course they are like concerned about the magnitude. However, if we take the above direction to be positive and the ball is coming downwards in the downward direction, so therefore it must be having minus sign attached to it. So therefore this is minus 20 meter per second, okay, downwards. But if when they are asking the magnitude, it can be like just 20 also that can be written. This can be solved by another way also, which is if you see the work, power and energy, so the energy is going to be conserved. Okay, so here when it has reached a height of 20 meters, so the energy is mg into h, which is mg into 20 meters. And now when it has reached the bottommost point, the potential energy is 0. And here the potential energy was this much, kinetic energy was 0, but here the kinetic energy will be half m v square. Now the total energy should be the same, so therefore both of them addition which is the total energy, it must be same. So therefore half mv square should be equal to mg into 20 meters. Mm is gone, so v is equal to root over 2 into g, which is 10, into height, which is 20, so root over 400, which is again 20 meter per second. So that's the again by work power energy also we can see the total time of the journey of the ball. Okay, so here what you have to do is you can solve it in two ways. Again, let us find the time. Okay, so to find the time, so you see the ball goes up and the ball comes down. Okay, now this is the final position, this is the initial position, so therefore displacement is going to be 0. Okay, now let us take, we have already taken upward as positive, so therefore 0 is equal to ut plus half at a square, and u we had already found out was 20 meter per second. So u is equal to plus 20 u into t plus half into acceleration due to gravity, which is minus 10, and this is t square. Again, displacement is 0 because final and initial are at the same position, so therefore it's going to be 20t minus 5t square should be equal to 0. So this is a quadratic equation. 5t square minus 20t is equal to 0. 5t we have taken as common, so therefore t minus 4 is equal to 0. It is having two solutions, t is equal to 0 and t is equal to 4 seconds. So of course in the beginning, initially at t is equal to 0 second, the displacement was 0, and finally at t is equal to 4 second, now the displacement is again 0. So therefore t is equal to 4 second is going to be the answer. Sometimes students also find it the time to going up and then the time to come down. So for the time to go up, okay, so this was 20 meters. So we have s equals ut plus half at a square, so 20, so this is positive, so therefore s is equal to plus 20. Plus 20 is equal to ut, so plus 20 into t plus half into acceleration due to gravity, which is minus 10 into t square. So 0 we are cancelling, so this becomes t square by 2 minus 2t plus 2 is equal to 0, which is t square minus 4t plus 4 is equal to 0. So this is basically t minus 2 whole square is equal to 0, so therefore t is equal to 2 seconds. So 2 seconds is to go up. Now coming down, so here the initial velocity is 0. Okay, so and it has to come down, so again taking upwards only as everything positive, so displacement is downwards, which is minus 20 is equal to u into t, u is 0, plus half into acceleration, which is minus 10 into t square. Minus minus becomes plus, 0 is gone, t square equals 4, so therefore t is equal to 2 seconds. So 2 seconds in going up, 2 seconds in coming down, so therefore total is 4 seconds. Thank you.